When we talk about the end behavior of a polynomial, we're looking to see what the ends of the graph do. So as x gets really big or as x gets really small, do the ends of the graph both point down? Does one end point down and one end points up? That's what we're looking for. We don't care about anything that might happen in the center of the graph, any of those hills or valleys in the polynomial, but really what the ends of the graph do. And so we can use end behavior to figure out what our degree of the polynomial is, specifically whether we have an even or odd degree. If the ends of your graph both point in the same direction, for example, this first graph, they both point down, or this third graph, they both point up, that's your indication that you're dealing with an even degree polynomial. So the highest power is going to be even, 2, 4, 6, 8, 10. We could do a little more investigating to find out more, but for now I know that it's at least going to be an even degree. On the other hand, if the ends of your graph both point in opposite directions, that's your indication that you have an odd degree polynomial. The highest power is 1, 3, 5, 7, and so on. So the second graph and the last graph here both have ends that point in opposite directions, so there's your odd degree. The second thing we can figure out is whether the leading coefficient, the number in front of the polynomial, is positive or negative. Sticking back with our evens, since both ends pointed down, that would be an indication that not only is it even, but it's an even negative polynomial. On the other hand, if both ends point up, that's an even positive leading coefficient. And then for your odd degree, you can do something similar. If you start low but end high, there's your example of an odd positive. It goes from the low to the high end as you look left to right. And then the reverse of that is, of course, going to be your negative one. It starts high but ends low. So there's an odd negative polynomial. These bottom two examples then ask us to describe the end behavior. And while there's a way to do this a little more mathematically than what I'm going to show you, I prefer to just describe end behavior using a picture. And so to find end behavior, I need to look at two things. I need to look at the degree, and specifically, is it even or odd? And then the leading coefficient, and specifically, is it positive or negative? So my degree is the highest exponent. I can see that it's 5, it's odd. And then my leading coefficient is the number in front of the polynomial. Make sure you're written in descending order, meaning the highest degree is in front, otherwise rearrange it. This time my leading coefficient is negative. So an odd negative, as we talked about up above, is going to go in opposite directions and start high and end low. So the end behavior of this polynomial, I'm going to describe it just with a picture that looks like that. This may or may not be what the polynomial looks like. There may be dips and dives and hills and valleys in the center. I don't care about that though. For the end behavior, I know it's going to look roughly like this. The ends will point in opposite directions, one high and one low. Okay, my second polynomial down here, once again, I need to find what the degree is, and specifically, is it even or odd? This time it's an even degree polynomial, so the ends of my graph should point in the same direction. My leading coefficient, I need to know if it's positive or negative. It's a fraction, that doesn't matter. All I need to know is that it's positive, and even positive will point in the same direction and both ends will point up. So the end behavior of this polynomial will look roughly like this. That does not mean the polynomial itself necessarily looks like this. There may be hills and valleys there in the center, but the ends of the graph will both point up.